So, in previous questions, when we solved our simultaneous equations, we were finding the point of intersection of two lines, okay? So, we said that that is one unique solution, okay? We said it's unique because it is one solution, okay? There's only one of them. Sometimes, though, there's more than one solution. We found that yesterday. So that's if there's more than one point of intersection, or sometimes there's no solutions at all, in which case there is no point of intersection. So we're going to have a look at this question. I want us to have a go at it and see what you notice. So some people have looked at this yesterday, but we want to formalize it as a note so we have it that we can refer to if we're doing a review or if we're doing so like in 6 months' time you can go back and revisit this if needs be. Alright, what are we multiplying the first equation by? What do you want to multiply by?
5. The first one by 5.
Okay, and then the second one by?
-2.
-2, okay. Now remember, depending on what you multiply by, it's absolutely fine. We should get the same answer, okay? So let's multiply the top one by 5. I end up with 20x. Take away 5 8s are 40 equals -15. Bella wants to multiply by -2, so this becomes, yep, good, positive 50 minus
40y
equals, right, and am I going to add or subtract?
Subtract.
Subtract. Now when I subtract, I get 0, 0, so I get 0 on one side, and on the other side I get
9.
9, yes, -15, and it's going to become add 24, so I get 9 out, okay? So obviously something funky is going on here. What do we think is happening? Because obviously 0 does not equal 9. Ella?
There's the parallel lines.
Okay, so they may be parallel lines. Why can I show that these two lines are parallel?
Well, you can put it into y equals mx plus b form.
Right, okay. If we put them into y equals mx plus b or plus c form, we'll be able to see if they're parallel. Now, if I do that, how do I know if two lines are parallel if they're in this form? Sally?
If the gradients are equal.
Right, and what is the gradient in this name? M. Right, okay, so let's quickly just do this. If I've got 4x minus 8y equals -3, so let's put this into this form. How can I rearrange this to make it y equals? What's the first thing I can do? Come on, everyone should be participating. What's the first thing I can do to make this y equals? Fine?
Subtract the 4x.
Okay, I can do that. So I would have -8y equals 3 subtract 4x. Sorry, that's -3 subtract 4x. And then to make y equals, divide both sides by? Right, -8. So I end up with y equals
1 over 2.
Yep, it's going to be 3 over 8 because it's a negative over a negative. It's going to be plus, I'll write it as 4 over 8x. Okay. So what is the gradient for this equation? Yep, 4 over 8 or 1/2. Okay. Let's have a look at the other one. Okay. Even. So I've got -10x plus 20y equals 12. If I move this down a little bit, I'll add 10x to both sides. I end up with 20y equals 12 plus 10x. Divide both sides by 20. I end up with 12 over 20 plus 10 over 20x. What is the gradient for this one?
1/2.
Right, the gradient for both of these is the same, okay?
So that verifies that it is in fact the line.
Right, so this tells us that the lines are parallel. Now, how do we know, because we talked yesterday about the two lines being exactly the same thing, how do we know that these are not two lines that are exactly the same? Right, they have a different y-intercept. Okay, so I'm just going to also write here. These are our y-intercepts, correct? So y-intercept is different. So the two lines are parallel.
Would this be like a 5 and 6? This is not a 3, 4.
Yeah, it would probably be about a 5, 6, I would say. Yeah. So the important thing to realize is, if you end up, I'll just scroll back down, if you end up, when you do your elimination with a 0 on one side and a number on the other, okay, we can say that the two lines are parallel, and if I want to communicate exactly what's going on here, what should I write? Sienna?
Well, because the as proven, the slopes of the lines are the same. No, the gradient.
Let's go back to the question.
Okay. You know what? Starting now, I'm going to do something. Find the solution. What am I talking about?
To find the solution to this, what have we found?
Solution. Oh, wait. In finding the solution, the results have shown that the lines are parallel.
Right.
This can be proven by converting the equation into slope-intercept form.
Okay, stop right there. Stop right there. Listening? Okay, we don't need to overcomplicate things. But we want to find the solution to these two equations, yes? That's what we're trying to do. What have we shown? What?
We've shown that it's you can't find it.
No. I've tried to find it, but what have I found?
There is
no solution,
I got
right?
it.
There is no solution. So therefore, there is no solution.
Why is there so
So therefore, there is no solution. Okay? And that's a valid answer. Okay, you can write down there is no solution to this. Okay, because the two lines are parallel.
I've never said it is like
numerical results?
What I'm going to do is just verify this, just by quickly drawing them. Okay, so the first one was 4x minus 8y equals -3. And the second one was minus 10 x plus 20. Alright, so there are our two equations, okay? They are drawn, we can see that they are parallel, they do not intersect, okay? So there is no solution, okay? Make sense?
Except Sienna's
I didn't sound like people that I want to, but like I don't sound like.
Is the following, okay? So I want us to determine what is going on with these two. So these are similar as well to the one that we did yesterday, okay? Find solution. So Christian, you didn't have your book? You didn't have your book?
That's why he went to the bathroom.
Okay, so I want us to have a look at this one and try and figure out what is going on here, okay? So let's have a look at this one. What do we want to multiply each of these by? Let's get somebody who hasn't given us an answer today. Brandon.
The top one by 2.
Yep.
And the bottom one by -3.
Okay, right. So let's do that. If I multiply the top one by 2, I get 12x plus 18y. Bottom one by -3, I get 12x
Plus 18y equals 24.
Alright, so I end up with the same thing. So when I subtract these, I'm getting 0 on the left-hand side and 0 on the right-hand side. Now, what is this telling us? We discussed these ones yesterday, Sam.
That they're the same line, so it has a big number.
Right, they are exactly the same line, okay? If I was to take one of these, 12x plus 18y equals 24, and rearrange it, I would have 18y equals 24 minus 12x. Divide both sides by 18. 24 over 18 minus 12 over 18. Okay. 4 over 3 minus 3/3 x. Okay, so both of these equations are exactly the same thing. They've both got the same gradient, and they have both got the same y-intercept. Okay, so they lie on top of each other. Now, what did we say yesterday? If this is the case. Always the same people. I'll have to make reference to that. So we've got the two lines lying on top of each other. So what does that tell us? That's me.
But the lines are exactly the same.
Okay.
And they're,
Alpha lines
oh, I have,
are exactly the same. So they lie on top of each other. Are they parallel out of interest?
No, because they're already.
No.
They are
Yes,
parallel.
they are.
They are parallel, they
But
are.
they don't intersect.
Okay. So what does that tell us, Maya?
that, there's an infinite number of interstitial intersections.
Okay, good. There is
Also, or solutions, whatever you need.
an infinite number of solutions. Yes, Adam. Now, we can actually go a bit further with this. We didn't talk about this yesterday. What? So there's an infinite number of solutions. Okay? I could not write down all of these solutions because there's...
I know one.
We did know.
I can generalize what the solutions are. Okay, now this is going to seem a bit
Would you
strange.
have to do this on a test, like generalized?
Yeah, but the lucky thing is it's dead easy because imagine these are two lines, okay? I've got the red line and I've got the dotted black line, okay? And they're lying on top of each other. All the solutions, what can you tell me about the solutions? They all lie
On the line.
on the line, okay? So what is an equation of the line?
Oh, well,
Bella? Can you give me any equation of the line in different forms?
yeah.
So all the solutions lie on this line. So the solutions are
The line.
the line, right? Okay, the line.
Raise your
Six
hand.
X.
Sorry, it just came to me and I had
When
to
I say the
express my
answer, no,
feelings.
raise my hand.
Well, 6x plus, what is it, 9y? 6x plus 9y equals 12?
Yeah.
Wait, is that one of the answers?
So that is,
Well, it's not simplified. Sorry.
it's
Oh,
not,
you really.
Guys are really tough. It's a good thing. It's a good thing. You just get benefits. Don't work it out.
okay, because remember the solutions lie on the line, so the equation of the line is a way that we could write all the solutions. This is, all the solutions lie on this line. Okay, but the thing I want us to remember is if there is an infinite number of them. Okay? No. Okay, so Sally, let's get all this fine.
Since the lines typically infinite, don't you have like
Arrows in the line. Yes, they were like, nobody wants
Joe, you got it all?
I used to do that.
In music it was.
Okay. So just to have a quick look, I'll put this back up in 1 second, okay? And on Desmos, just to show, just to make sure, to verify, these two equations were 6x, what was it?
Plus
9y equals 12, and then the other one was?
-4x minus 6y equals
Okay, oops, like that.
-8.
Oh, negative, thank goodness for that. Okay, and the two lines lie directly on top of each other, okay? So every point on that line is a solution, okay? Good. Alright, so to summarize, is it okay if I put it there?
Yeah.
Christian? Okay, right? Alright, so to summarize, last bit of writing. When solving linear simultaneous equations, we can either so what's our possibilities? We could either have
When what? Specific, a unique solution.
one unique solution. Okay, good. Okay, we could have Neil. Yep. And the other one is Sally. Infinite number of solutions.
What about,
Okay, good.
what come there also be more than one point for that?
Now, there could be more than one point, but this is why I've written the word linear, because what does linear mean?
Straight.
Straight line, okay? So if it's two straight lines and they cross, they're only ever going to cross at one point.
Oh, right.
Okay? But good question, because if I had, you can remember what a quadratic looked like. What quadratic looks like. Okay, it either looks like that or it looks like,
A U or a.
okay, so either a sad base or, so if I had a quadratic and let's say a linear, I could have a possible two solutions, okay? That is something we will get to, okay?